Every single piece of tech we build eventually reaches the end of its life. But what happens when that technology is a nuclear reactor? The pioneers of the atomic age are getting old, and their final chapter is being written as we speak. So let's dive into one of the biggest, most complex engineering challenges happening quietly all over the world. How in the world do you safely take a nuclear reactor apart? Just think about this for a second. Since the 1940s, we've built more than 650 of these research reactors around the globe. And these weren't just power plants. They were these incredible hubs for science, for medicine, for innovation. They were game changers that really redefined what was possible. But, of course, time moves on. And get this, more than half of them, that's over 350 reactors, have already been permanently shut down. So this massive retirement has been quietly happening in the background for decades now. And that wave is far from over. If you look at the reactors that are still operating today, more than 200 of them are over 30 years old. They're getting to the end of their design life, which means, they're next in line for decommissioning. So what we're really seeing is this kind of great reactor shutdown. But look, this isn't some kind of crisis story. It's the story of one of the most complex, high-stakes, and honestly, one of the most fascinating cleanup jobs in human history. To really get the challenge here, you have to remember the era these things were built in. Back during the Cold War and that first big rush of atomic optimism, the focus was all on building and operating. And the whole idea of taking them apart someday, well, that was kind of kicked down the road, a problem for later. There's actually a report from the International Atomic Energy Agency that just perfectly nails this old mindset. It described a perception that decommissioning was an, quote, easily manageable activity, needing no advanced planning. Basically, the thinking was, we'll figure it out later. It was someone else's problem to solve, way off in the future. But later always arrives, right? And that way of thinking created some very real problems. Cleanups got delayed for years, the money wasn't set aside, and crucial building plans were lost. And maybe worst of all, the original engineers and operators, the people with that priceless institutional memory, they started to retire, taking all that critical knowledge right out the door with them. Right, so something had to change. A whole new playbook was needed, fast. The global nuclear community, with the IAEA at the forefront, started this massive coordinated effort to turn decommissioning from this afterthought into a precise science. Okay, so what does this new science of decommissioning actually look like? Well, let's take a super common problem. You've got these microscopic radioactive particles just clinging to surfaces. The old way of cleaning this up involved a ton of water and chemicals, which, you guessed it, just creates a brand new problem, a whole bunch of liquid radioactive waste. So engineers in Belarus came up with this absolutely brilliant solution. It's essentially a high-tech peel-off face mask, but for radioactive surfaces. You spray on this special liquid polymer, it dries into a solid film, and then you just peel it right off. All of those nasty contaminants are trapped inside that solid film, which is way, way easier and safer to deal with than a bunch of radioactive liquid. And let me tell you, the results are pretty incredible. This table shows something called the decontamination factor, or DF. All you need to know is the higher the number, the better. So look at that galvanized steel, a DF of 40. What does that even mean? It means they removed 97.5% of the contamination in just one go. That is just incredibly elegant and super efficient. Okay, so cleaning surfaces is one thing, but what about the biggest, baddest challenge of the whole job? Taking apart the reactor pressure vessel itself. This is the very heart of the reactor. Thick, heavy steel that's been bathed in radiation for decades and is now seriously radioactive itself. Let's look at a perfect case study, the BR3 reactor over in Belgium. This cross-section here really shows you the scale of what we're talking about. You can't just send a crew in there with cutting torches. No way. The entire job has to be done remotely to keep everyone safe. And a lot of the time, that means doing it underwater, since water is a fantastic radiation shield. So the team at BR3 cooked up this incredibly audacious plan. Instead of trying to chop this thing up in its cramped original spot, they said, you know what? Let's lift the whole 28-ton thing out in one piece, move it, and then dunk it in a big, deep pool. That would give their remote-controlled cutting machines way more room to work. But this is where the past comes back to haunt you. First off, they found out the original blueprints from the 60s? Not so accurate. Their brand new, custom-designed equipment literally didn't fit. Then, once they got started, all this old rust and insulation junk started floating around, making the water so cloudy the remote operators could barely see what their tools were doing. It's just a perfect reminder that this isn't some perfect, clean process. It's all about adapting and solving problems as you go. So, these amazing techniques prove that, yeah, we can do this. We can take apart even the most complicated parts of a reactor safely. But the job isn't done when the last piece of steel is cut. There are still some really big, long-term questions that the whole world needs to figure out together. So, what's left on the to-do list? Well, for one, getting every country to agree on the exact same standard for what's safe enough to be treated as normal waste. Then you have the really big one. Where do we permanently put the waste that's still radioactive? We need final disposal sites. And perhaps most crucial of all, we've got to take all these hard-won lessons and use them to train a new generation of experts and to design new reactors that are actually built to be taken apart easily from day one. So in the end, as this first generation of nuclear reactors finally closes its last chapter, the lessons we're learning right now, they aren't just about cleaning up the past. They are literally the blueprints for creating a safer, more responsible, and truly sustainable nuclear future.